Hi folks, back again for day, what is it, 7 already of Advent of Code. Still F sharp, it's still early for me. Yesterday was a bit of a rough one. So let's see what today has in store for us. We have 3 minutes to go. So before the puzzle unlocks, I'm going to take a quick look again at what my colleagues have been doing. We have a public GitHub repository somewhere. I'll put the link in the description. But we're doing a friendly challenge in a couple of categories, like super beautiful, elegant code, super hacky code, stuff like that. So I'm gonna take a quick look at what my colleagues have been up to. Python is still the most popular language, and I see a lot of C#. That's surprising, or especially surprising because I only see one Kotlin and one Java. It's a bit .NET heavy this year, and Python, of course. MIPS, that's something assembly languages like. Yes, it is. It is seriously impressive that only a crazy person. He's been solving, I think, the last 6 days, so the entire Advent of Code in assembly. Gotta admire dedication. I don't think I could be able to do it for 6 days in a row. It's I don't know if he has like formatting or indenting help, but it's super readable, super structured. I would not mind diving into the actual tidbits of this code. Cool. I would like to see them in action. How do you program assembly? Do you have an IDE? Is it just a text editor? I'm curious. That's an interesting one. TypeScript. Is this the only JavaScript language? Yeah, here's some. Let's go straight to the good parts. Part 2. That is a lot less lines of code than what I had to write or what I wrote yesterday with my solution. It's funny to see how functional JavaScript has gotten in the last years. This was something I had not seen when I started programming in JavaScript, and now in the last couple of years, maps and filters and for eaches, they are everywhere. Nice, concise solution. I like it. Python, yeah, we know Python is great. We know Python is awesome. Java. I have not seen Java code for years now. I know they do stream, or like they have collection functions. There are even tests. Cool. Again, very readable. Like it. Only funny part about Java is that there are a lot of folders to click through. Wait, there's another file. There's another file, which is just the main. Okay. It's interesting. This is more OO, or not more OO. It's just Java, so it's OO by definition. But even the design, or no, we have only one object, but still, it appears to be more structured, or the problem has been broken down into more chunks. Yeah, again with the collection functions or the functional flavored stuff. It's mainstream now, I think, or maybe I just have a lot of colleagues that have been brainwashed just as I have. Never thought to see the day where a reduce function would end up in a Java code base. Yeah, this looks really similar to what I've been doing. Cool, I like it. I'm keeping track of all the days because we have to find some nominations for the voting this week. Shall we look at the C# one? Of course. It is my main programming language at work. So let's see. Wow, 24 lines of code. And with the new .NET 6 stuff. You don't need too much boilerplate like namespaces or main methods. You can just write a C# file, dump your script in and run it. That's an improvement for at least for silly stuff like this or for one-off scripts. I like it. Yeah, can't get any more concise than this in C# at least, I think. Cool. I see that the code or the puzzle for today is actually unlocked for a couple of minutes now, so enough waffling. Let's dive into the puzzle. The treachery of whales. A giant whale has decided our submarine is its next meal, and it's much faster than we are. There is nowhere to run. Okay, so that's a Wikipedia hit for whale. Cool. Suddenly, a swarm of crabs, each in its own tiny submarine. That is awesome. It's too deep for them otherwise. Zooms in to rescue us. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. Okay, so the crabs are little helpers. That is awesome. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help? There's one major catch. Crab submarines can only move horizontally, of course. You quickly make a list of the horizontal position of each crab. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match, while requiring them to spend as little fuel as possible. Okay, so they all have to line up, and they need to spend fuel to move. So these are for example set. I'm gonna grab that and put it in my old trusty example string. Maybe while we're at it, let's grab our own input, which is a bit larger. It's a single line, so I'm just going to read all the text in that file. And let's not split. So we have 2 lines with horizontal positions. Yes. Cool. What does this actually mean? This means that there's a crab with horizontal positions 16, 1, and so on. Yeah. Each change of a step in one position of a single crab costs 1 fuel. That's easy. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. Oof. That's an interesting problem. I have no idea how to solve it. How do you figure out the most interesting horizontal position? Maybe do a distance from every point to every other point and see and sum them or something. Yeah, and then see which one has the least, or at least when we're optimizing for fuel cost. But we're optimizing for fuel cost. Yeah, okay, so that might work. So yeah, this is just the difference between where we want to go and where we are. That is correct. More expensive outcomes include aligning to another position. Yeah, okay. Determine the horizontal position that the crabs can align to using the least fuel possible. I think the approach I just outlined might just work. So the approach is to calculate distances from one point to every other point, and then from the perspective of one point, look at how far every other point is, sum them up, and then we can find the... Or actually, that is the full fuel calculation for every point, or for every 2 points. That is the brute force approach. Which is not too bad, I think. How many numbers do we have? Let's quickly parse our input. Figure out how many numbers we have to compare. So it's just a split on comma and a map. So we can parse integers. I think integers are good enough. Yeah, looks like it. And let's drop into the list world because I like my lists. (16, 2, you roll up 14. That is correct. I'm gonna drop those in tests. Not that it's too much of a mind-bending parse, but still. Beroepsmisvorming. Let's parse the input. What do we expect? We expect the code to run. That's start. We expect 129. Yeah, that looks correct. How many do we have? 1,000 numbers exactly. So that's 1,000. That's quite a bit of numbers, but let's go with a silly, naive brute force approach first. So for every distance, calculate, or no, for every horizontal position, calculate the distance. For every other point, I'm gonna do one more check. Do they all start on a different position? So I'm gonna put everything in a set that deduplicates. So if there are any double numbers, it gets rid of them. Yes, we have duplicate starting positions. It might be interesting when we're starting to loop over everything. So we don't forget that there are multiple hits for certain positions. So let's start to loop over everything. How do we do this elegantly? Do we need to do this elegantly? Can we do this like with a for loop? Of course we can. For a position in positions, let's call this positions. So I'm gonna grab a variable where we parse something. Let's parse the example. And then for every position, if you do something like for every element in a list and then for every other element in a list, you can do a nice trick. And let's do this trick here. Where we don't have to start from the start, but we start from the start for the first element, and the next element we always take like one further ahead the starting position. So what does indexed return? The index comes first. So let's call it Y to stay in the conventional for loop world. And then for J, maybe an array is actually better. Now I have to do this like list item. Yeah, let's make this an array, which allows a instantaneous access at a certain index. That's better. Here it does not make sense to do that, but here it makes sense to... can I do a slice? Can I do like starting from y plus 1 up until the end? Yeah, it looks like we can. Let's make a pair of those. Now that I say let's make a pair of those, I think there is a function that does what we are doing. We don't need the j even. We have not indexed that second iteration. So is this what we want? 16 and 1, 2, blah blah blah, up until 14? No. I see 2 14s. No, it's a 4, sorry. Yeah, and then for 1 we go up, up, up. Yeah, let's see if this built-in function I'm thinking about, I think it's called all pairs, whether or not it does the same. Positions. Do you do the same? No, you do not. Aha, okay. It forms pairs or combinations for 2 lists, not all pairs in a single list. Makes sense. So let's keep our own custom hand-rolled double for loop, or a for comprehension representing the same thing. Now we just need to... Let's put that second... Oh no, we can't do this smart thing. or we can do this loop optimization thing because can we? Now, for part 1, I don't think we should, because we don't only need like the distance from 16 to 1. When we're processing 1, we would like to also do the distance from 1 to 16. Yeah, so let's not do this optimization. Might be wrong here, but I'm gonna try it anyway. So I am going to index that thing twice. And then if I equals G, then we don't do anything. And if I does not equal J, is that how you do does not equal in F sharp? That's yeah, okay. If I does not, why? I does not equal J, then we can return the position, next position. Yeah, and I think if we do something with an if in there or a conditional, I noticed that it didn't complain about me not having a yield keyword in there. Is that actually true? Interesting. So 16, 1, 2, blah, 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 up until 14. And then it takes 1, 16, 1, 2. So it skips over the 1. That looks correct. Our test is failing because I changed it to a arrays instead of a list. I think right now we have all other positions for every point. And now it makes sense to group that second iteration separately. So we have, for the first point, we have the list. For the second point, we have a list. For the third point, we have a list. What is the last point? 14. So it should start with 14, 16. Yes, and should end with 14, 2. Yes, that looks correct. I'm calling it all pairs, which is the name of that function that did not do what I wanted it to do. So that's confusing. But anyway, is my auto formatter working? No, that's funny. I was playing around with it yesterday, and it is like I can reproduce it. If I open the options menu, that's when the formatting kicks in. So right now I see that it's formatting. So I need to open the settings menu. Oh, could not format, unexpected error. Wait, did formatting just break? Yeah, formatting broke everything again. Or am I blaming it on something else than myself? Well, actually, I am the problem. Okay, formatting works and everything appears to still be in working order. So, sorry for this little detour. Yeah, there we go. So these are all the pairs. Yeah, let's just count the steps taken, which equals the amount of fuel we need, and then sum everything together, and then look for the minimum. And I think that is it. We don't even need to know that position. We need to know the fuel spent. So, all pairs. Let's map. So then we have pairs of locations. And for every pair, or for every list of pairs, we do a map again, which takes point A and B. And we should do a difference between them. Yeah, let's make that A minus B, and let's do absolute value. Let's sum those up. So then we have the list of all sums. Yep, and I think if we take the minimum of that, we are done. 37, is that correct? Yeah, 37 is correct for the example. Cool. I'm wrapping everything in a function so we can call it for our input. Not necessary when speed coding. I do like it when I'm taking my time and enjoying the puzzle. So let's try to solve the example again. It should give 37, that is correct. Let's put it in a test. And let's solve the input. Yeah, that already took more than a millisecond. All right, cool. Part 1 down. Let's go take a look at part 2. Before I make any other steps, let's copy paste the part 1 file. And let's continue on. The crabs do not seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, crab submarine engines do not burn fuel at a constant rate. Instead, each change of one step in position costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. Yeah, this actually impacts the solution strategy as well, I think. A lot of small moves are better than one crab that has to move a whole lot. So maybe it makes sense to go to the... Yeah, I think it might change. So as each crab moves, moving further becomes more expensive. This changes the best position to align them all on. Yep. Oh, this costs a total of 168 fuel. This is the new cheapest possible outcome. So that more than doubles the example fuel. What happens if we try the naive strategy? So we keep the algorithm as is, but the fuel calculation, that's something we change. So that actually translates to this. This is the distance, but it equals the fuel cost. But in the new strategy, this is the distance still, but the fuel cost is way more than this. Yes, I think so. So let's do the naive thing first. Let's try to hard brute force it by just doing a more complicated fuel cost calculation. This is already a brute force, so let's keep doing that. Let's hope it is performant enough. So what changes? Sum by still okay. Let's extract this into a function, and that function is called cost, move cost. Yeah, wait, what was it again? Okay, so it is so that is the position, which is the cost for part 1. So sum by, let's do the destructuring of a tuple outside of the function. And then we need those arguments around. This should still work. Does it still work? It does still work. Okay, so now we can take a look at a smaller sub-problem, which is this. This is for part 1, but for part 2, the move cost is different. What is the first step? Can we do like start from point A or B, whatever is the smallest, and take a step until we reach the distance, and every time we just increment by one more. So first move was 1, second move was 2, third step costs 3. Yeah. So actually the movement costs are I thought this was something I could do. Do you need an end? Oh, interesting. Yeah, let's do the approach outlined in my head just a second. So let's look up the smallest number. So we have something that only increases. Min. What does min do? What does min actually do? Min takes two functions and values and returns something. So I'm gonna hard code an example here. Or I'm gonna play around in the REPL with an example here. That's what I mean. Okay, so this works. So this is the minimum distance, then should be 3. Yeah. So starting at, do we need to know min? No, we don't need to know min. Distance is enough. Because from, what is it? 0 to distance, I think we can have 2 points at the same time. Does it make sense to start? So we need to move to 11, 12, and 13, which is 3 moves. So if we do this, these are the actual costs. Yeah, these are the actual costs. So in theory, I don't know about the 2 costs or the 2 points at the same. Let's just try that out actually. So distance should be 0, and then we go from 1 to 0, which I don't know what F sharp will do, but we expect the move cost to be nothing. Oh, that works actually. Neato. I am going to write some tests for this. So moving to where you are costs nothing. Do we have an example? From 16 to 5 should give us 66 fuel. Oh no. From 16 to 5, 66 fuel. That's interesting. Where are we going wrong? What? So the distance between 16 and 5 is 11. So I'm just gonna feed it to the REPL. 16, B is 5. It cannot do this. Okay, let's put that on a new line then. I am sorry for even trying. It is 11. So from 1 to 11. First step takes 1. Second step takes 2. 11th step takes 11. Is that not correct? What? That looks correct. 66 is what we expect. Why is it not showing me 66? Did I not have the latest version of the code in my REPL? Select everything and just try it. And then give it some time because there's this NuGet download for a verification whether we have a NuGet package or not. It's really slow today. There we go. It's currently solving part. Oh no, it's actually doing the full solve. Yeah, that looks better. Huh? That looks better. It's failing because our part 1 solution is in here. It should be 168. Oh no, we are off by 2. No. Yeah. We say it's 170. It should be 168, right? Do we see a special case in here? I see a 0. That might be something that is not working. Yeah, I'm just going to try that. And if we don't find it, we'll start debugging. So from 0 to 5. It should cost us 15 fuel. That is costing us 15 fuel. Okay, let's debug this. What are we going to debug? I'm just going to print out the result of this function. So know your weird characters. Okay, A, B, cost. And let's just return cost after we print it. Let's not solve it just for now. And let's run. Oh, God. Nope, I didn't say anything. I thought I was running on this wrong data set. Wait, what is actually this? This changes the best horizontal position, so horizontal position 5. We need every calculation for the 5 case. So move cost between 5. Nope. Oh. 5 is not actually a position given in the starting string. That's interesting. Did we like luck out on part 1? Any horizontal position? Yeah, I think we lucked out on part 1. Because it already... Could it have been a problem there? Yeah, I think so. But, so, 5 makes sense. But then we need to change our strategy a bit. Instead of comparing all the pairs here, we should do that, but we shouldn't do that from position 1 to position 2, where positions are things in the list. We need to do it from any location to any position we're given. Yeah, so actually let's loop over 2 different arrays here. One is the positions we've been given. But the outer loop, let's make that something else. Let's call it, let's call positions here crap positions. And let's create a second list, which is all locations. And that goes from, I don't know what's the first crap position, or maybe even 0 to like somewhere last crap position. Yeah, that'll work. So from first crap position to last crap position. I need to do this a lot, like select the minimum value of an array and select the maximum value of an array. I don't know if there's like a helpful function that does both in one line. Not that it matters that much. So let's create a location list going from first to last. Not the band, mind you. And then all locations is where we need to loop over. Let's call this location. And then we don't need to filter out a location anymore. Nope. So we can get rid of the indexing. Well, our problem is becoming simpler by doing this, I hope. In theory, this should give us a better solution. Let's see what we get for the example. 168. That's better. So I'm gonna remove the debug print and let's run all the tests. Yep, that works. Let's see whether our CPU can handle the real problem. How about no? No, it's stuck. We might have to tweak. How will we tweak this? How will we make this more performant? What's the insight we need to gain here? Hi chat. Have you solved today's puzzle already? I'm working on part 2 and I think I have the brute force algorithm down, or a brute force algorithm, but it's not fast enough, or at least it's burning my CPU for the real input. So I'm now trying to figure out how to do this smarter. I actually just got an answer from my code, so let's see whether or not this is correct. It is correct, but it took, I think it took a minute. So let's go back, see how long it takes, and whether or not we can speed this thing up. So it actually works, but it's really, really, really slow. How could we make this faster? Can we do something like yesterday with the fishes? We have a bit of, or we have crabs in the same position, and we might end up with a lot of crabs in the same position. Maybe that speeds up process. What else can we think of? So right now we just grab all the crab positions and we start to look at all locations from the most leftmost crab to the rightmost crab. And then we just do a distance calculation for all those combinations. Maybe we can make this a bit smarter. Is there a way to more easily calculate the cost given a distance? Right now I'm generating a list for every time we do that and summing that list. And it's not really a difficult list. It's like always 1, 2, 3, 4. Is there an easier way to calculate a cost that grows like this? Yeah, those are two avenues we could investigate. Cost calculation and the main strategy, whether or not we have to do this for all the things. How long did it actually take? 40 seconds. I think we can do better. Wait. This can be that hard. Let's write out those costs. We see the pattern, but I don't see the actual values. Yeah, I'm just gonna drop them in here. So we have 1, 3, 6. What is this reminding me of? 10, 15, 21. Is there a way to calculate these types of costs without doing this? Or is there a faster way of doing it? What is the actual... 11 is too much for my brain to handle. Let's do a cost between smaller numbers. 3 and 6. So distance is 3, yes. And cost is 6. 3, 4. Oh yeah, it starts from 1, of course. So yeah, let's maybe do one more so things get a bit more interesting. So the distance is 4. We should end up at 10. 3, we should end up at 6. 2, we should end up at 1. 3. I am not seeing it. No, I think I need more coffee to solve this problem faster. Which is probably exactly what I'm gonna do. No, the coffee machine is down the floor. It's we have, oh, it's only 6:37 right now, local time. I'm gonna give it 20 more minutes, and if I didn't figure it out then I'll take a coffee break and try again. What is the smarter way to do this? If we group the number of crabs in the same location, I think we only cut the search space in half. Yeah, because those are 1,000 numbers in the input. And when we looked at how many unique items were in there, there was something like 600-ish numbers. So that would still mean we have to do this algorithm for only half the input. And then we need to do some bookkeeping to keep track of how many crabs are in that position. So optimistically speaking, I think that only reduces our execution time in half. And most of these problems can be solved in under a second if you know the trick. So what is the trick? What is the trick? Let's take a look at some more examples again. No, I'm thinking maybe we're flying at this in the wrong way. Is there an easier way to figure out the optimal position? I don't think so. No, not without calculating the actual costs. Nope, mind is totally blanking. I'm not seeing a better way. So I think I am going to take a short break, fuel some more coffee, and hopefully we have this aha moment, this eureka moment. But otherwise, we solved it. It's not the fastest algorithm. It won't be the best approach to do this, but it works. Perfect is the enemy of good enough, right? Let's call it a case of perfectionism. All right, I'm gonna cut the stream here. If you know, or if you have the faster algorithm down, I am really curious about what the trick is here today, so please let me know. Other than that, have a nice evening, morning, wherever you are. Enjoy the rest of the day. I'll see you next time. Let's maybe check if we can raid someone. Is everyone offline already? I know. Let's go take a look at Anthony writes code. Bye-bye. Apparently it takes a couple of seconds when a raid starts. Did not know that. Learning every day. I have no idea what this rate thing is doing. I'm a total Twitch noob. What is even happening?